The Islamic prohibition on figurative representation shifted the focus of artisans to the written word. In North India, Arabic calligraphy became the primary form of monumental ornamentation. This is the baseline for early Islamic architecture. We see complex Arabic calligraphy bordered by geometric patterns on red and white stone. To make the text visible, artisans carved letters directly into the stone, using shadow to create legibility. Compare that to the apex of Mughal architecture. The Taj Mahal scales this integration across massive domes and soaring archways. Between 1540 and 1649, calligraphy evolved. It transformed from a surface-level carved relief into a deeply integrated, polychromatic inlay program. This transition shows that Mughal calligraphy was a highly engineered system of material science and spatial design. To understand how this leap happened, we will track specific variables across a single century, holding the geographic location of North India constant. This matrix tracks the evidence. We will map the year, the monument, the calligraphic style, the technique, the material, and the identity of the calligrapher. Tracking these specific data points reveals a clear trajectory of technological progress. We will populate this matrix using 6 specific monumental case studies. Completing this dataset explains how an imported Persian textual tradition synthesized with indigenous Indian stoneworking. The first node in our timeline is the year 1540. The Qila-e-Kuna Mosque in Delhi serves as our structural baseline. Our first dataset is locked. The year 1540, at the Qila-e-Kuna, using Kufic and Naskh scripts. It is a carved relief on red sandstone and white marble, created by an anonymous calligrapher. We see the limitations of this baseline technique here. The calligraphy is carved directly into the curved red sandstone. This creates a geometric problem. Early horizontal scripts, like Naskh and Kufic, are difficult to scale on towering vertical structures without losing proportions. We see early attempts at visual contrast, like this vertical white marble panel, where the carved text is framed by a darker geometric border. Despite the craft, the artisan remains hidden. The calligrapher for this monument is entirely unknown. At this stage, architectural calligraphy is constrained by horizontal scripts and anonymous craftsmanship. We move forward to the period between 1574 and 1612, under the rule of Emperor Akbar. Akbar shifted the capital and the architectural scale. This is the Buland Darwaza. Massive vertical archways required text that remained legible to viewers standing far below on the ground. The solution was typographic. Compare the horizontal baseline of the Naskh script at the top with the stretched vertical stems of the Thuluth script in the middle. Thuluth's verticality solves the problem of perspective distortion on tall archways. Here's that script in practice. Complex, vertically stacked Thuluth carved into light brown sandstone. Logging this data, we see the shift to the Thuluth style at the Buland Darwaza and Akbar's tomb. In the rightmost column, the status of the artisan changes. They are no longer anonymous. Imperial calligraphers were now signing their names onto the architectural facades. Typography successfully adapted to 3-dimensional geometry, moving the calligrapher into a position of prominent artistic agency. The timeline advances to 1628, with the tomb of Itmad-ud-Dawla. This monument marks a shift in the base building material. The entire structure is made of white marble. Our matrix now shows the tomb of Itmad-ud-Dawla, utilizing Thuluth on a white marble base, carved by Abd al-Nabi al-Qarishi. There's technical friction here. The building material upgraded to marble, but the text is still applied through carved relief. The tomb occupies the moment where the canvas reached its final form in marble, but the text was still applied using the older carving method. While the architectural canvas had reached a premium state, the physical method of applying the typography had not yet evolved to match it. We reach the climax of the timeline, the period between 1646 and 1649. Builders solved carved stone limitations with a technical breakthrough. They began pressing precisely cut black stone into marble channels to create a perfectly flush surface. Replacing the variable shadows of carved relief with high-contrast flush stone creates a result that remains visible regardless of the sun's position. The matrix is now complete. The Taj Mahal and Jami Masjid represent the jump to inlaid work and the use of the Tughra style. The Tughra script allowed for complex radial packing of text within arched spandrels. Amanat Khan was the calligrapher responsible for the text of the Taj Mahal. He was granted a level of agency rarely seen in the court, acting as a co-designer of the monument. He ensured the text was thematically programmed to match the building's specific function. Amanat Khan selected verses regarding divine mercy and paradise to intentionally complement the funerary nature of the tomb. By 1649, calligraphy was no longer just applied to the building. It was structurally, geometrically, and thematically engineered into it. Our completed matrix shows a century of progress. We see a clear trajectory: sandstone to marble, carving to inlay, Naskh to Tughra, anonymous labor to titled mastery. The matrix proves each iteration was a measured step forward in material science and spatial logic. The verticality of the scripts specifically solved the geometry of towering archways. The shift to flush inlay secured permanent, high-contrast legibility. This framework is essential for modern architectural historians and conservationists. Modern conservation of these sites fails if the text is treated as generic stone masonry. Accurate restoration requires understanding the precise modular typography and material intent of the original calligraphers. Mughal monumental calligraphy proves that at the height of the empire, the written word did not just decorate the architecture, it dictated its final form.